Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving deeper into the world of concurrent programming in Java. We're continuing our chapter on executors and thread pools, and our focus today is on the ThreadPoolExecutor class. Victor, are you ready to unravel this powerful tool for us?
Absolutely, Sheila. I'm excited to explore ThreadPoolExecutor with our listeners. It's a cornerstone of Java's concurrency framework, and understanding it well can really level up your multi-threading game.
Before we jump in, let's start with a quick quiz for our listeners. Here's the question. How does a ThreadPoolExecutor handle task overflow when all threads are busy and the work queue is full? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It touches on some key aspects of ThreadPoolExecutor's behavior. Listeners, as you ponder this, consider the various strategies a system might employ when it's at capacity. How would you design a system to handle more work than it can immediately process?
Great point, Victor. Now, let's start with the basics. Can you give us a high-level overview of what ThreadPoolExecutor is and why it's important?
Certainly. Think of ThreadPoolExecutor as a team manager for a group of worker threads. It's designed to efficiently handle multiple tasks by distributing them among a pool of workers. This approach is much more efficient than creating a new thread for each task, especially when you have a large number of short-lived tasks.
That's a helpful analogy. So, if ThreadPoolExecutor is like a team manager, what are the key components we need to understand?
Great question. The main components are the core pool size, maximum pool size, and the work queue. Imagine the core pool size as your full-time staff, always ready to work. The maximum pool size is like your total workforce capacity, including temporary hires. And the work queue is where tasks wait when all workers are busy, like a to-do list for the team.
I see. So how does ThreadPoolExecutor decide when to create new threads versus queuing tasks?
It follows a specific process. When a task comes in, it first checks if all the core workers are busy. If not, it assigns the task to an available worker. If all core workers are busy, it puts the task in the queue. Only when the queue is full does it consider creating additional temporary workers, up to the maximum pool size.
That makes sense. Can you tell us more about the different types of work queues we can use?
Absolutely. There are several options, each with its own characteristics. The most common ones are the unbounded queue, which can hold an unlimited number of tasks, the bounded queue with a fixed capacity, and the synchronous queue, which hands off tasks directly to threads without storing them. The choice of queue can significantly impact how your thread pool behaves under different workloads.
Interesting. It sounds like choosing the right queue is crucial. What factors should developers consider when making this choice?
Great question. Developers should think about their expected workload. Will they have bursts of tasks or a steady stream? They should also consider memory constraints, as some queue types can use a lot of memory if not managed properly. Task priorities might be important for some applications. And of course, performance requirements play a role, as different queues have different speed and efficiency characteristics.
That's really helpful, Victor. Now, let's dive a bit deeper. How does ThreadPoolExecutor manage the life cycle of its threads?
ThreadPoolExecutor is quite sophisticated in its thread management. By default, it keeps core threads alive indefinitely, but you can change this behavior if needed. Non-core threads, on the other hand, have a timeout period. If they're not used for a while, they're terminated to save resources. It's like sending temporary workers home when there's no work to do.
Fascinating. It seems like there's a lot of room for customization. What are some advanced configurations developers can use to fine-tune their thread pool executors?
You're right, there are many ways to customize. Developers can control how threads are created and named, define what happens when the executor is overloaded, start core threads in advance to reduce initial delays, and even add custom logic before and after task execution. It's like having a fully customizable workforce management system.
Wow, that's a lot to take in. Can you give us an example of a real-world scenario where understanding these configurations would be crucial?
Certainly. Imagine you're building a high-traffic web server. You might use a ThreadPoolExecutor to handle incoming requests. You'd want to carefully set your team size based on your server's capabilities and expected load. You might use a queue with a fixed capacity to prevent memory issues during traffic spikes and implement a plan to gracefully handle overload situations, perhaps by sending a server-busy response.
That's a great example, Victor. It really illustrates the practical importance of understanding ThreadPoolExecutor. Now, are there any common pitfalls or misunderstandings that developers should be aware of?
Absolutely, Sheila. One common mistake is setting the maximum team size too high, thinking it will improve performance. In reality, this can lead to resource exhaustion and decreased performance due to too much multitasking. Another pitfall is using an unlimited to-do list without proper monitoring, which can lead to memory problems. It's crucial to understand your workload and system capabilities when setting up a ThreadPoolExecutor.
Those are important points to keep in mind. As we wrap up, could you share some best practices for working with ThreadPoolExecutor?
Certainly. Here are a few key best practices. Start with a relatively small core team and increase if needed. Use queues with fixed capacities to prevent resource exhaustion. Keep an eye on your thread pool's performance and adjust as necessary. Consider using different pool configurations for different types of tasks. And always give meaningful names to your thread pools for easier troubleshooting and monitoring.
Thank you, Victor. Those are excellent tips. Now, let's reveal the answer to our quiz question. How does a ThreadPoolExecutor handle task overflow when all threads are busy and the work queue is full?
Great question. The answer is that it depends on the rejection policy configured for the ThreadPoolExecutor. By default, it throws an exception to say it can't accept the task. However, you can set it up to handle overflow in different ways, like having the submitting thread do the work itself, quietly ignoring the task, or even creating your own custom approach.
Excellent explanation, Victor. To summarize today's episode, we've learned that ThreadPoolExecutor is a powerful tool for managing concurrent tasks in Java. We've covered its core components: task submission process, queue types, thread lifecycle management, and advanced configuration options. Remember, the key to effectively using ThreadPoolExecutor is understanding your specific use case and tuning the pool accordingly.
That's a great summary, Sheila. I hope our listeners found this deep dive into ThreadPoolExecutor enlightening and practical.
In our next episode, we'll be exploring Scheduled Executor Service, which adds timing capabilities to our concurrent toolbox. Don't miss it. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth explorations of Java's internals. Until next time, happy coding.